Today we are going to see about error probability in feeding channels with diversity reception. Narrowband system, flat feeding channel, single tap channel model, performance enhancement through diversity are the narrowband systems. Adjacent symbols do not affect the decision process if there is no intersymbol interference. No intersymbol interference at decision time instant. Received replicas of the same symbol overlap in multipath channel. However, fading is still possible. This graph shows the narrowband system's bit error rate performance. In y-axis, the bit error rate is calculated and in x-axis, signal to noise ratio is given. In a flat fading channel, the channel impulse response reduces to a single impulse scaled by a time varying complex coefficient. The received signal is of the form R of t equal to A of t e power j psi of t into S of t plus n of t. We assume that the phase changes slowly and can be perfectly tracked. This assumption is important for coherent deduction. Activity. Imagine folding a paper in half once. Then take the result and fold it in half again and so on. How many times can you do that? We assume the time variant complex channel coefficient changes slowly. The channel coefficient magnitude A is a Rayleigh distributed random variable. Coherent deduction of a binary PSK signal is assuming ideal phase synchronization. By using this assumption, let us define instantaneous SNR and average SNR. The instantaneous SNR, gamma equal to A square into EB by N naught, Y naught equal to E of A square into EB by N naught. Since P of A equal to 2A divided by E of A square, E power minus A square divided by E of A square, in which A is greater than 0, using P of gamma, we get P of gamma equal to 1 by gamma naught e power minus gamma divided by gamma naught, in which gamma greater than or equal to 0. These are used for Rayleigh distribution and exponential distribution. The average bit error probability is P of E equal to integral 0 to infinity Pe of gamma and P of gamma d gamma, where the bit error probability for a certain value of A is P of gamma equal to Q of square root of 2A square EB by N naught, which is equal to Q of square root of 2 gamma. It is for 2 PSK signal. We thus get the error probability P equal to integral 0 to infinity Q of square root of 2 gamma into 1 by gamma naught e power minus gamma divided by gamma naught d gamma, which is equal to 1 by 2 into 1 minus square root of gamma naught divided by 1 plus gamma naught. Approximation for large values of average SNR is obtained in the following way. First, we write the bit error probability equation. Then we use square root of 1 plus x equal to 1 plus x by 2 plus and so on, which leads to the probability of error approximately equal to 1 by 4 gamma naught. This graph shows the bit error visit signal to noise ratio for fading channels. A summary of these various types of techniques used and its bit error probability is given. The assessment questions. Thank you.